Welcome back guys to my channel, and in the video we'll talk about load combination. So load combination just when you combine different loads to a structure in order to see how the structure will perform under different conditions, right? So and those loads can be the self weight of the structure. It can also be the live loads. The live load, just the load from people, the loads from furniture, the load that can move, can vary. Okay. We also have the seismic load. Seismic load is when our planet, our Earth is moving, like the earthquake, right? And also we have the wind loads from two directions, right? So I explained to you last time about this, right? So and into the video we'll talk. I'm gonna use the error codes. So error code is just a code that provides different sets of load factor for combination. For combination, okay? And I will observe the ultimate limit state, which deal with the safety of the house, and also the serviceability limit states, which ensure the, how can I say, the comfort of the building. Okay, all right. So let's start, guys. So at the end of this video, if you find this video both entertaining, educative, guys, share the video, like the video, and for more content, subscribe to the channel. Okay, guys, let's start. So as you can see, this is my Matlab. And I start already. The first line is clear. Clear is just to make sure that the workspace is empty, right? I'm gonna show you later the workspace. I'm gonna show you, and also the CLC is to clear the comment, the window comments, right? To make it empty. Okay. And the first thing that I'm gonna do to define my load combination, to explain my load combination. So I'm gonna define all of all the load that I have already. Okay, so I mean have the dead load. Of course, you have to calculate the dead loads, right? I have it already, and I have the live loads. I also have the value, specific value here. I also have the wind loads. So I have the specific value here, and I also have the seismic loads, right? I have the specific value here, right? And all of these, the kilonewton. Okay. So after this, you have to make sure that all of these units, they're constant, they're similar, right? So don't change the units. If you change the units, you're gonna have a wrong result. Okay. All right. Okay. So first, for the second step, I will show the combination of ultimate limit states, right? So ultimate limit state, I said that is about the safety of the house, right? So I'm gonna include for the first combination, I'm gonna include the wind loads, and for the second combination, I'm gonna include the seismic loads, right? So this is really important. This is the extreme condition, right? So ultimate limit state is really important, right? So for the stability of the house, so you have to know how to combine the load properly. And these numbers that we have here are 1.35 and 1.5 here. That is safety factor, all right? This safety factor is allow us to combine all of these loads without any complication, any mistake. Okay. So each code has different value, but I'm using the error codes, right? I told you, right? So if you're in different country, if you're in India, if you're in any country in Africa, we have different thing. We have different codes. If you're in Europe, in any country in Europe, you also have a specific codes. If you're in America, so we have different codes, right? Australia, the same, right? So each continent has different. It's not only continent. It's sometimes each country, right? They have different codes. Okay, so you have to observe the code properly. All right. So here, as you can see, the first condition, I'm gonna just use I'm gonna combine the dead load, live load, and the wind load. So for the dead loads, I need to take the safety factor of 1.35 times the value of the dead load that we have it already, and then plus the live loads times its safety factor is 1.5. This will never change, like in error code, this value will never change, right? So every single time in your structure, if you're not combine dead load and live loads, you have to use this coefficient here, this safety factor here, right, for ultimate limit states. And I'm gonna also check the wind load, so I need to take also 1.5 times the wind load. So this collabo here, this combination here will never change. All right. And And for the second part, I'm gonna also consider the seismic loads. So I'm gonna combine the live load and the dead load. Those ones should be the main combination, right? And then here the factor is changing. For the seismic loads, we have a 1.0, okay? For the seismic loads, you can see the difference between the wind load and seismic loads, right? For the wind loads, the safety factor is 1.5, but for the seismic load is 1.0, right? So you have to make sure that this value here, the constant. Yeah, so don't change this value here, okay? So the objective of this point of this combination just it allow us to evaluate how the structure will behave during a strong windstorm and also earthquake, okay? All right, so I'm going to do the same for the serviceability limit state. All right, for the serviceability limit states, I'm gonna do the same process, but here I'm gonna focus on comfort and usability rather than safety, right? Because I told the serviceability limit state just focus on comfort, on our structure comforts, right? And usability. Okay, so it's gonna be under the structure gonna perform under the normal circumstances, like under normal condition, right? And you can see the value that's decreasing, right? So you can see that for the first combination, the S signified. So this S here means serviceability, and this U here is also means ultimate limit states, right? So you can change the name according to your preference. So don't need to follow me. Okay. So the value here it become from 1.35 it become 1.0. Okay. You see? So we change it because it should be low, like it should be in normal condition. This one is the extreme condition. The ultimate limit state is for extreme condition. But here for the serviceability, it's about, as I said before, it's about usability and also comfort of the house, right? So we can see the safety factor become smaller than the one for ultimate limit states. Okay, so we can see for the combination you can 1.0 times the dead loads, and then plus 1.0 times the live loads, and then here becomes 0.6 times the wind loads. And here I'm gonna also focus again on seismic load for the second combination. So I'm gonna just take the same combination for the live and the dead load, 1.0 times the dead loads plus 1.0 times live load plus 0.3 times the seismic loads. Okay, so from this summary you figure out that the wind loads has higher impact on the building than the seismic loads, right? So you can see every single time the safety factor of the wind load is bigger than the one for the seismic loads. And for the snow load, it's gonna be the same also. The snow load gonna be less than for the seismic loads, right? Yeah, so this is how we can do the combination, the load combination. So I'm gonna just print the results and then I'm gonna explain again everything properly to you. So for printing the results, so I'm gonna divide it into two. The first display should be the ULS results, and the second display should be the SLS, sorry. And you can see all of the combination that included. So I'm gonna explain again. So I'm gonna use the fprintf. Many people that are familiar with these codes, right, in Matlab. So fprintf just to print the results, by the way. So I put the first combination. So if you use this part here, means that this just this gonna be the title, and I'm gonna explain again. So from here, I just use the code. Like let me take the first combination. I put fprintf just to print this result for the first combination. So I put the first combination. I use 1.35. Everything, all the combination that I did, like 1.35 times the dead load, 1.5 times the live loads, 1.5 times the wind loads, right? Equals to percentage those 2F, right? And kilonewton and N, right? So this percentage here, right? I just want to indicate that the format, so it should be the format. I'm gonna use this specify format. This F is just a specify format, and I like my formats to be so I like my value to have two decimal points after. I mean, if you have 6.668, it should be only 6.67. All right, so two decimal, and the kilonewton here is the unit, so the value should be, so after the value the unit should be displayed, and this n means that's a new line. So after the result is printed, my code should start a new line. Okay, so this is the meaning of this part here. All right, and yeah, and the prints, the result should come from this equation. The equation is here. If you just click on this u, 1, you're gonna end up to this equation. Okay, so I'll repeat the same for the second combination in ultimate limit state, and I did the same process also for SLS. Okay, so I'm gonna go on run my results. If there's any mistake that I did, the computer will tell me to change it. But if there's nothing, you might be able to see the result. All right, so you have to save your coding, and I'm gonna save it as untitled. I don't wanna put any title yet. I'm gonna put untitled, let's say 200. Okay, and I'm gonna save it specific folder. I'm gonna just leave it the way it is, so I'm gonna save it specific folder. All right, so if you wanna see the results, just open this parts, and yeah, this is the parts, like Matlab parts, right? And you can see the results, right? As I said, I use the clear to clean the workspace. The workspace is clean. These values are from this code here, and I use CLC to also clean the comment window. So the comments window was empty before, right? So as you can see here, the first display result that we have is 1.5 GL plus, like the title that I put. Do you remember the title that I told you, right? For the display, for the displaying the result, right? This is the title, and the result is this is the result of the combination. So our structure should be able to withstand this magnitude, these forces for the load combination of the win load, live load, and the dead load. Should be also the same for the dead load, live loads, and the seismic loads. So our building should be able to carry this load without collapsing. And for serviceability, it's also the same idea, the same comparison. Okay guys, so this is the end of this video. I hope that you found this video entertaining and also educative. Please support me. Guys, support me, subscribe to the channel, share the video, and like the video. See you in the next one. Bye bye.